Hey, okay, I got Alexis, I got Deborah, I got Tiara. Hey, Deborah.
Hello.
Hey, Alexis.
Hey.
Hey, Dion. And hey, Tiara.
Hey.
Tiara, can you close that curtain behind you? I can't see anything but a big black blob. Okay. All right. How you guys doing today?
Um, you know,
Yeah. Yeah. I need to talk to you about some things in terms of grading papers because it's the next problem I've got to solve. One thing I want you to do when you send me your homework is rename your scan. Some of you did that, but put your name on it and then put like parts quiz. And that's, just rename it. A couple of them are coming through with just like a string of numbers on them for the scan. And that's okay. I sorted it out by opening them, but the next thing I got to figure out is how to avoid what I did last night. When I started to print some of them off, I couldn't read them. So anytime you're doing anything like that and you're scanning it, make sure you got a dark pen and maybe you write a little bigger than possible than normal if you can. But the thing I really want to do is load it into this thing that I'm showing you my lecture notes on and grade it on top of that. On top of I'll change it. Yours is a PDF coming to me from scanning, and I want to grade it on top of it and see if I can email it to you. But for some reason, every time I hit email, it won't send for me. So I got somebody that's going to talk to me about that this afternoon. So there may be some changes in terms of sending me things, but for right now, just send them. The other thing I want to talk to you about is what's on Moodle. I hope you've looked on Moodle. There's the sheet there. The assignment sheet is there. There was one thing on it I noticed that I had forgotten that I did, and I put that there was a quiz on trig forms and that it was due today. Make that due tomorrow, and I've already posted it on there. Trig forms so there's nothing really due today, guys. It's just due tomorrow. And the next thing after that is it says partial fractions, but we're going to go over partial fractions today. So really right now, the only thing that's due immediately is what's tomorrow. And I've put 3 or 4 problems from section 9.2. So look over those. Don't worry about the quiz on partial fractions. There's another quiz on Friday, and that's on quadratic and miscellaneous forms. And we're going to talk about that homework today. So if you had trouble with that homework, we'll talk about it. Also on Moodle is what's called an integral guide sheet. And that integral guide sheet is just sort of a way to keep yourself organized. If it looks like this, try parts. If it looks like that, try substitutions. All of that stuff is on there. It's a whole written kind of guide as to what you might want to think about anytime you look at an integral. And we're going to do some of that today to look at some integrals and so forth with those problems in the back of your calculus book. The calculus book is so thick, you'll be amused at this, I'm sure. The calculus book is so thick that I couldn't scan it very well because everything down in the fat crack won't scan properly. So I got a razor blade and I started cutting pages out of my calculus book so I can scan them better. I do have another book, so I usually feel bad about when I do things in a book. I couldn't even write in a textbook because I was afraid I wasn't supposed to mark it up. I think that comes from grade school somewhere.
my textbook.
So anyway, you'll see some of that stuff that I've scanned in here on those cutout pages. We're gonna do tomorrow more just integrals again all day tomorrow. But look on Moodle again. There's a set of 12 integrals, and what I want you to do, this is for tomorrow, what I want you to do is just go through, do as many of those as you can, and even if you can't finish them all, start them and see what you can do with them, or what you go down some road, and if you can't finish them, we'll look at them and see how the road's working out. Okay. So we're doing integrals today. We're doing integrals all day tomorrow. Okay. I don't have anything new to tell you about integrals anymore for right now. So the last thing was the miscellaneous and that thing. But okay. So anybody have any questions? Everybody okay? All right, so what oops, I don't want to do that. So what I want to do right now is, let me get my screen on and share it with you and see what we got here. Hang on one second. I'm gonna look at the parts quiz that you had. Most everybody did fine on that. So I'm gonna look at it and just sort of point out a couple of things about parts. That's the one that I tried to grade. I couldn't print it out, so I was standing there looking at the computer writing notes. So you may not have understood my notes. So I want to talk about that first. Okay. Let's see if I get this. Get off Siri. I don't want Siri. Okay, so let's see. I want to share the screen and this and that. Okay, so there's my screen, guys. I'm going to look at this parts key first, and we're going to just make sure everybody understands what got done on that. I mean, like I said, everybody did pretty well on this thing. Can everybody see it? Is everybody okay? Hands up. Everything good? Thumbs up. Okay. All right. So on this this first one, that was clearly a parts problem because two things multiplied that really don't have much relationship to each other in terms of substitution. You did just the right things. You let u be that x, and you let dv be the e to the 5x. There were a couple of errors on finding v. You're integrating e to the 5x. So instead of multiplying by 5, you divide by 5. So that thing right there, that was an error that a couple people made. After that, you just put in uv minus v du, and this came down here. And then once again, the integral of e to the 5x is e to the 5x over 5, which put another 5 down there and gave you 25. Okay, so so that looked pretty good. Almost all of these look pretty good, so I'm not particularly worried about parts. All right, so the next one, it was just that inverse cosine, and you really don't know exactly what to do with it, but you guys did the right thing. You let u be the integral. You let u be inverse cosine, then you let the other thing be the 1 dx, and when you integrated that, you got x, and then you got x inverse cosine minus x times this thing. But this was a nice substitution problem because you had the 1 minus x squared there, and you had the minus x up there, so you were only differing by a minus 2x. That one looked really good. Stop me if you don't see, you're not okay, but I think everybody's pretty much okay on these things. The second one, the third one, this was clearly a parts problem again, and we let u be x squared, we let dv be sine x. When we integrated and used parts, we saw we had another one to do because there was an x cosine x there. Be careful with your signs in here. U is x, dv was cosine, integral of cosine is sine. Went down this road right here. You had one more thing to integrate, and Dion, you got all the way down here, and then I think you just sort of looked at that and you forgot to integrate it. But the integral of, that was minus 2 sine x. The integral of sine x is minus cosine x, so there was plus that. And I should have put a plus c on it, and I didn't. But anyway, everybody was pretty good with that until the minor error right here at the end where you forgot to integrate that last thing. Okay. All right, this one was an interesting problem. L comes first in that LIATE thing, so we let u be log t, du is 1 over t, dv was the square root of t, and then when I integrate that, since that's t to the 1/2, it'll be 2/3 t to the 3/2. 2/3 t to the 3/2. Tara, you were kind of messing up on your inverting and multiplying there, so take a look at that. But so here, this was t to the 3/2, t to the 3/2 over 3/2, but when I invert and multiply, it'll be 2/3 there. So that's how I got that. And then minus 2/3 t to the 1/2, integrate that. Right here, one other thing, this thing right here, when we did v du, there's v and there's du. This is not a log, guys. That might look like a log if this had been added to that. But what you do is just simplify it. t to the 3/2 over t to the first is just t to the 1/2. And then that's easy to integrate. And you get a 4/9 there. Okay, that's not a log. You need to simplify before you start making those kind of decisions. Okay, everybody good so far? Like I said, this looked pretty good. All right, on 5, another one that was pretty easy. I let u be x. I let dv be cosecant squared. The integral's minus cotangent. We just went from uv minus b du. We know the integral of cotangent is log of sine x. Everybody got that one just fine. I gave this bonus, and I just sat there staring at it last night. I was like, what did I do? This is a string of products here, guys, and it's not added, so you can't separate them. You can't split that off in terms of a sum. It's multiplied. So and this is a good rule of thumb here. What I eventually remembered, it's my own rule, and that's you want to let, let's see if I can get it down a little bit. You want to let dv be the hardest thing that's easy to integrate. And if you look at all of this right here, that's pretty easy to integrate. Because if you let u be cosine, then du is going to be minus sine. Look right down here. All right. So, or right here, really. If u is x and you let that be dv, it's easy to integrate. Again, it's just a simple substitution. Let u be cosine, and then you get the minus there because the derivative of cosine is minus sine. And du is dx. So it's uv right here minus the 1/3 that came from integrating the cosine cubed times the integral of cosine cubed. Now, this I left here. This is one of those we haven't had a quiz on yet. If you want to integrate cosine cubed, what you're going to want to do, suppose you want to integrate cosine cubed. This will be a good review for that quiz that's due here. That's one of those things where you want to try to split something off, okay? Well, they're only cosine, so it's pretty clear I'm only going to split a cosine off. And that'll leave me with cosine squared. And the reason I split the cosine off is so it could be the derivative of sine, which means I'm going to change that to sine, which is 1 minus sine squared x. And then this again is cosine x. And then it's easy from there, because you're going to let u be sine x. du is going to be cosine x, and then it's pretty easy to, it's pretty easy to integrate there. My hand touched it. Rats. Okay, so that's how you're gonna do that one. It's cosine x. So I can let you finish that one. But that quiz looked good overall, and a couple people got the bonus. All right, so that was good. I gave the quiz was worth 10 points. I gave 2 extra points for the bonus, so that's why some of you got a little bit over 10. Okay. All right. So is everybody cool with parts? Yes. Okay. All right. So let's go back here. Question?
So
what?
It said that part, the last bonus part, was supposed to be a bonus quiz.
It was. I gave you +2 on it. So the highest you could get was if you got something over 10, if you got the bonus and you got everything else right, I put 12 in there instead of a 10. You see what I'm saying? I
thought it was gonna replace a quiz, but that's okay.
Oh, you thought it was gonna be a whole quiz?
Yes.
No, I put it as a bonus on the quiz. I'll think about it. Okay. Yeah, Dion.
It didn't look like you graded my bonus one.
I thought I did. Do you have? Would you mind telling me what your score was on it? On the whole thing.
It said it's an 8 because I got 4 1/2.
Okay. Let me go look. Let me look back at it. Okay, and I'll correct it if I need to. Okay.
Mm-hmm.
Okay. Did it look like you did it right based on what I did?
Think so.
Okay. All right. I'll tell you. I'll look back at it and see. Okay. Anybody else? Okay. So let's go Next, I want to go to the partial fractions. Now, this was kind of a mixed up mess for a couple of reasons. I gave a partial fractions quiz before y'all left, and then I didn't have a copy of it because I left my copy at school, so I didn't really know what was on it. And so I posted another one on Moodle, and so at least Dion, I think, did the one on Moodle, and then Tara and other people were trying to do the one that I had given out that day in class. So everybody, we're going to look at these problems together, and I'm just going to call this a wash basically and give everybody a 10 on this quiz, okay? Well, you can tell me what you tried and what worked, what didn't work, okay? So let's look at some of the partial fractions stuff first. Okay, let's see if I got what I need here. Now, let me do first. I'll tell you what I'm going to do first, and I'll let you guys kind of look along because some of you might not have seen the quiz on Moodle. This was the partial fractions quiz on Moodle, and let's talk about the setups and so forth and so on, and see what happens on this. I think Dion did this one. Did anybody else do the quiz on Moodle? Okay, so let's just look at what's going on here. Basically, I want you to see the setups. Notice here that when you factor this, it's the product of two linear factors. So when you set it up, it's just going to be A over one and B over the other. Now, it looked like to me, I mean, you could do it two different ways. Once you get these fractions cleared out, you could start with this way, where we could drop out things. So for example, if I let x equal 2, that thing right there is going to drop out. If I let it be 2 right there, that's -3. That makes a equal to -1/3, okay? If I let x equal 5, that one drops out. 5 minus 2 is 3, and so I get b equal 1/3. Dylan, you tried this one, and I think you made a sign error right in here when you did it by substitution. That's the other way solving a system of equations, just solving a system of equations. You can say, well, ax and bx, the coefficient on x is 0 over here, so a plus b is 0. Minus 5a minus 2b is the constant, so it's got to be 1. I think what happened is you didn't see your negative sign right there, and I think you got 1/7 or something like that on it. But anyway, it should have been 1/3 and minus 1/3. Then it's easy to integrate. Both of those things are natural log. One with a minus 1/3, one with a 1/3. Turned out to be pretty easy. So that one, I think people are probably doing okay on that. All right, let's look at the second one on the quiz. First thing you want to check now is that the power on the numerator is less than the power on the denominator. If not, you got to divide. We may run into that a little later. But notice this, guys. This is what's called a repeated linear factor. It's not a quadratic. It's not irreducible. It's x plus 3 times itself 3 times. And that just means basically that we could have a common denominator. Whoops. We could have a common denominator in it that had an x plus 3, an x plus 3 squared, and an x plus 3 cubed. So if you see these repeated linear factors, just start with one and step up on every succeeding fraction to the highest power. I will say, when you do this and you clear out the fractions, there's only one thing that's going to make things drop out here. What's the value here that's going to make things drop out there, guys? Hold your fingers up. What's the value there that's going to make things drop out? 3 with a minus, okay? -3. So if I let, I sort of thought about that to begin with, because if you let x be -3, these two drop out. That says c is, whatever, 43 on this one. Yeah, or c is, yeah, or 9a plus b plus c is 43. Anyway, I multiplied it out, and then I started matching coefficients. There's the x squares. So there's only one of them. So ax squared is 5x squared. That means a's got to be 5. So that's kind of easy one to find. Let's see if I can get that one. That says a is 5. Now, the next one I did was look at the x's. 6a plus b was the x coefficient. So I put 30 there. But because I already knew A, I put it in, made it 30, subtracted 30 from both sides, and I got B equals 0. So always use, if you can, what you've already found, and you'll save yourself time. The last one was the constant, 9A plus 3B plus C. We knew A was 5. We knew B was 0. We didn't know C, but we knew that the constant was 43. So doing that, I get C is minus 2. Okay. So it actually turned out to be a pretty easy problem. It's 5 over this minus 2 over that. That first one's a natural log. This is just a power rule problem where I let U be x plus 3. So there, U would be x plus 3, du would be dx, and it turns out to be just an easy power rule problem. Okay. All right, everybody okay with this? Okay. All right. So we go. The last one on that sheet looked like this. And again, let's look at the setup, and then I'll let you sort of look through what I've done. In the setup, it's a linear factor. This is an irreducible quadratic. You cannot factor x squared plus 9. And ultimately, guys, what I mean by irreducible is if you were to use the quadratic formula on it, you'd get an imaginary root. You get a negative under the square root on the quadratic. Okay, so usually in partial fraction sections, they do ones that are kind of obvious here, like that one. So over x plus 3 is over x plus 3 is an A. Since it's an irreducible quadratic here, this is bx plus c. I'll let you look at it. I cleared things out. I matched the coefficients and then found out all these values were 1, minus 1, and 3. Does everybody feel good about once you get it set up, you can find out, you can match the coefficients or let things drop out? Everybody feel good about that? Alexis, you feel good?
Question.
Yeah, sure.
I think I just get confused when there's when you can't factor it out when there's 4 pieces, how you can split it up. And
Oh, you mean 4 pieces?
Yeah, that's what was on the other quiz, is that there would be 4 terms.
Okay.
And the expression, I wouldn't be able to reduce it.
Let me give you a hint on that, and then you can tell me which one it is in the book. I'll finish this and you can tell me. When there's 4 terms that you think they want you to factor, it's probably factoring by grouping. Group them 2 and 2, and then see if you can't get it out. You can show it to me in a second, and let me finish this, and we'll do that one next, okay? Do you know which one it was? Do you know? If you can find it, we'll do it.
Okay.
Okay. All right, so guys, let's see. This one, anybody else question? You okay? This one again, when I played everything out here, guys, I put a 1 over x plus 3, which is natural log. When you have something like this, it's better to split it up because one of them will be probably easy. So I split this into this part right here, and that's just another natural log. And then the other piece was 3 over x squared plus 9, which we know is just a trig substitution, okay? Which I proceeded to really screw up down here. And so I kind of had to mark through what I had, but that's what it looks like. Your trig substitution is going to be 3 tangent theta. You already had a 3 out here. And then we went down and we had that value right there. Okay. All right, so that's what I wanted to do on parts and partial fractions. There's one other thing, and this let's see. Pierre was asking me yesterday about the 2 from the book, a couple of those from the book. That was which one? Number 1. Okay, we'll do
this one and that one. I could not do.
Okay, let's look at them. Let's look at them and see what we got. Make sure you set it up right, and we'll go through it and sort of see what happens. You can check me as I go. So in 18, it factored into x squared and x squared plus 9. That means this is repeated linear because it's x times x. It'll be a over x plus b over x squared. This is an irreducible quadratic, so it'll look like that. Cx plus d over x squared plus 9. Okay, did you have it set up right? Alexis, you said you had a problem with it. Did you have it set up right?
No. What I did was I said a over x, b over x squared, and I said c over x squared plus 9, but I didn't say cxd.
Okay, Look, if
I
it's an,
think like that's what messed me up.
yeah, probably. If it's an, it won't work if you do that. It's an irreducible quadratic. What it is, you see, this is a quadratic form. This is linear here. The highest power of x is 1. It's always 1 less. If it's quadratic, it's linear here. If it's linear, it's constant here. Okay? So always if you have that irreducible thing, it's got to be cx plus d or ex plus f or something like that. Okay? We'll run into it again down here in a minute. So when I cleared out the fractions, I thought it would be easier, guys, just to multiply all this stuff out. Because you know what? You could do one thing. You could let x be 0, and that wouldn't be a bad thing. Because look what happens. Let's get back on here. Look what happens if x is 0. That term drops out. That term drops out. On the left-hand side, all of those drop out. You get minus 27. If you let x be 0 here, you get 9b is minus 27, so b's minus 3. That was an easy one. Always start with the ones you can let be 0. So I found one thing from that. I found just one thing, but it'll help me in the end. Actually, so we know that. The other ones, there's nothing else you can let x be to get anything to drop out, because x squared plus 9 is always going to be positive. Can't do anything to it. So I just said, okay, now I got to multiply it out and start to match coefficients. So I multiplied it all out. Let's double check my work here. Ax cubed plus 9ax plus bx squared plus 9b plus cx cubed plus dx squared. Okay. So the next thing I did was say I've got one. How many x cubed terms have I got? I got a plus c. You know, guys, and what I do is I kind of check them as I go along to make sure I've gotten them all. So a plus c has to be the coefficient there, which is 4. So there it is right there. A plus c is 4. Okay. The other thing I know, and I wrote everything I knew along here, if you look at the x squared terms, there's b plus d, and there's a minus 3 on x squared. So b plus d is minus 3. Now, I'll come back in a minute. The other one was the x term. There was only one of those. It was 9a. Right there's the x. 9a equals 6, so a was 2/3. So now I've got two things. I can find the other ones. If I know b's minus 3, I'll put b equal minus 3 right here. The minus 3's will drop. I get d equals 0. That's great. If I know a, which I just found, it's 2/3. A plus c is 4. Subtract 2/3 from 4, and I get 10/3. So here's how it all set up, guys. Now, I'll let you look at the rest of it, but that's an easy log problem. That's a power rule problem. I would suggest splitting this. Split that. Well, you know what? There's nothing else to do because that's a 0. That makes it great. That's a 10/3 x with the 2x. That's just a let u be x squared plus 9. It's just a natural log. And I got the 10/3 from there, and the natural log would have been a 2x, so I multiplied by a 1/2 there. Okay. I'm timing out on this. Long problems. Okay, everybody all right with that one? The next one, let's see what we got on the next. The next one actually looks messy, but it's actually not bad, but I want you to see how I set it up. It was x to the 4th plus 2x squared plus 4x plus 1 over x squared plus 1 cubed. Guys, that's a repeated quadratic. If it's a repeated quadratic, an irreducible quadratic, you got to do the same thing you did with linear. That is, step it up to the 1st, 2nd, 3rd power. But because it's irreducible, I have to put something x plus something in every one of the numerators. So this will be ax plus b, cx plus d, ex plus f. Now, it looks horrible at first because you know what? When I clear out the fractions, there is not a darn thing that's going to make any one of these things 0. Because you can't, I mean, if you let, you can't, because x squared plus 1 is never going to be 0. So immediately I went to multiplying things out. And when I multiply things out, hopefully I got it right, ax to the 5th, 2ax cubed, and so on. You can check it out. And then I started matching coefficients. Nice thing, there was no x to the 5th power right there. There was only 1 here. That means A's got to be 0. So A's done for. The next one was x to the 4th. I looked through here and I found out there was only 1 x to the 4th. So that means B has got to be 1, because that was the coefficient right there. B had to be 1. And so on. I put them all together. And in the end, a lot of stuff ended up being 0. F was 0, D was 0, C was 0. Put it all in up here. Pretty easy to integrate. Okay, this will be an inverse tangent. That'll be just a simple substitution problem with u equal x plus 1. All right, Alexis, do you have that when you were talking about not being able to factor?
Yeah, I think I understand what to do now. Like, I think I was just overwhelmed that like that can like be factored by grouping.
Mm-hmm.
And so like now I see it's really just about what's going on in the bottom.
Mm-hmm.
Because now I see why there isn't like AX plus B then CX plus D. It
Okay.
makes sense now.
Okay, all right. The thing I was talking about with grouping, I'm trying to come up with a quick problem right here that might help. 2x plus, hang on, x cubed plus x squared plus 2x plus 4. Look at this. If I had, suppose I had something that looked like this in the denominator. This is just a reminder of some factoring techniques. Maybe this one will work. If you had x cubed plus 2x squared plus 2x plus 4. Now, and that was in the denominator, guys. And we know that we need to factor when we're doing partial fractions. So if that one had been in the denominator, I'd look at it and say, well, I don't know what to do with that exactly, because I do need to factor it so I can get all these things over those pieces. So what I thought you were talking about, Alexis, was doing this. If you grouped and took an x squared out, you'd have an x plus 2. If you took a 2 out here, you'd have an x plus 2. And then you got common factors of x plus 2 there, so you'd get x squared plus 2 times x plus 2. And what we would see is that we had one irreducible quadratic right here and one linear thing. And then you could start from there. So maybe there might have been 1 or 2 of those in the homework, okay? So I thought that might be what you were talking about. Okay, now let's go. How about last night's homework? How about miscellaneous substitutions and so forth and so on? Anybody problems with that? Hang on, I'm gonna go get my cut up calculus book. I'll be right back.
Tierra.
Yes.
Did you do the math homework?
Yes.
I'm back.
I didn't know we had math homework.
I have a question about number.
Okay. Yes, okay. In answer to your comment about you didn't know we had homework, there was an online sheet with the homework on it, okay? And I put it at the bottom of the
little slides on
I think I put it at the
papers.
bottom of the slide too.
I didn't look on the Moodle.
Okay. Look on Moodle, and I've tried to put the homework on the bottom of the last page of every slide. But
Okay.
but anyway, so look at those. So
I'm
who
gonna
has,
look at
we can use Tierra, what you got?
Can we look at number 7?
Okay. All right, that was 7 and it was on page blah blah blah.
485,
That page from my calendar book
I
there?
think.
485. Okay. Oh, that's one of the cutout pieces.
Oh.
Number 7 on 485. Okay.
Mhm.
All right, got it. Okay, so here's what it looks like. Suppose the problem looks like this. The integral of the square root of x over 1 plus the cube root of x. One plus the cube root of x dx. Oh, my internet connection is unstable. That's not good. Okay, so guys, this was that miscellaneous substitution like I did yesterday where we had the two radicals that had a different index on them. They were different roots. So we had an x to the 1/2 and we had an x to the 1/3. The trick was to let u equal x to the 1/6. You remember that, Tiara? So you got started right. Okay. So the next thing, we don't want to take du from that mess. So we'll raise both sides to the 6th power and we get x equal u to the 6th. Okay? Then we'll find our du. 6u to the 5th du will be 1 dx. All right. So that's part of your substitution there. All right. Everybody good with that? Okay. So the next thing I'm going to do is this. If I had u squared, just to finish up the substitution, if I squared this and raised it to a power, that would be x to the 1/3. If I had u cubed, again, this is based on my original what u was, u cubed would be x to the 1/2. Excuse me. X to the 1/2. So I've got pretty much every single thing I need to do this problem. What's wrong, Sierra? I see a bad look on your face. Unmute yourself, please.
Nothing.
Okay. Nothing? Did you see what you did wrong, or did you?
Yeah.
Okay. I'll just plug in, guys, and then you can finish it out. Let's talk about how to finish it out. So the square root of x was u cubed. The dx was u to the 6th du. Is that right? No, I screwed that up. Wait a minute, that's not right. Okay, the dx was 6u to the 5th du, and then this was 1 plus that cube root of x was x to the 1/3 was u squared. All right, I'm glad we're doing this one, because if you look at this, this is 6x to the 8th. I mean u to the 8th. 6u to the 8th from up here. And it's all over 1 plus u squared. Okay, so what do I do next?
Pull out the 6.
Pull out the 6. That's a good idea. So I'm going to pull out that 6 and, okay, done. Okay, what next?
You know.
You know,
Oh.
guys, it looks like a rational expression, but there's only
Wait.
1 plus u squared up there, so that didn't do anything for you. The power in the numerator is higher than the power in the denominator. Oh, and Tiara says you got to do what?
Divide.
Got to divide. Look, if it's a rational expression and the power up here is more than the power down there, you got to divide. So let's do it. It's kind of messy, but let's do it. I want to make sure everybody's got this. Okay, so there's that. So it's going to be u squared plus 1. Don't forget you got 6 out there, but I'll worry about that later. Into u to the 8th. U squared into u to the 8th, u to the 4th. It's just like saying u squared over u to u. Wait a minute, it's not u to the 4th. What is it? What should it be?
The 6.
U to the 6th. U to the 6th. Sorry, screwed up. Okay.
Oh, no.
So if you put u to the 8th over u squared, you get u to the 6th. If I multiply out, I get u to the 8th plus u to the 6th. If I subtract, I'm down here with u to minus u to the 6th. What's u squared into minus u to the 6th? U squared into minus u to the 6th. Minus u to the 6th. Minus u to the 4th? Okay.
I mean 4.
4. Yeah, you're right. It's 4. So now I multiply again. U squared times minus u to the 4th is minus u to the 6th. 1 times u minus u to the 4th is minus u to the 4th. Next thing I do is change the signs because I'm subtracting. Finally, we're almost there, guys. What's u squared into u to the 4th? U squared, yep. Multiply again. Get rid of this thing down here. In my way. And then subtract. So that's minus U squared. All right, how many times will U squared go into minus U squared? Negative 1. Okay. If I multiply back again, that's going to be U squared minus 1. Minus U squared minus 1. Change the signs, I get a remainder of 1. So if I go back up here, my remainder of 1 will go over the divisor, U squared plus 1. Now, I'll let you guys kind of finish that out. You got the 6 out there. These things are easy to integrate. That's just a natural log. Remember to go back and put in your U. And your U was x to the 1/6, I think. Okay, so that's easy to take from there, I think. Is everybody okay with what I did there? If it's a rational expression and the power in the numerator is the same or higher, divide first, and then it turns into that. Okay, Alexis.
So like, are we dividing until we get like 1 or something?
Yeah, that's a good question. You divide until you can't divide this to the degree of this until the degree of this is less than the degree of that. So you can't divide U squared into it anymore. That's when you got a remainder. Okay. So if, for instance, if there had been a U down here, U squared won't go into U. It'll only go into something U squared or higher. So that's what your remainder is. Okay. It's like dividing 2 into 7. You get 3, you multiply, and then you get 1. 1's less than 2. So you just leave it as the remainder, so it's 3 1/2. So that's what happened. Okay. That's what's happened there. Okay? Anybody else have any problems on the miscellaneous substitutions? Either the quadratic forms or the miscellaneous substitutions? Let's see. Anything else? Anybody? Deborah, did you have one? Okay. I'm trying to find. Let's do one more thing here. We got about 8 minutes, so I'm just going to throw some things at you here. Nobody questions on that section. If you have any tomorrow, I'll pick them up tomorrow because we're just going to be doing all integrals all day long. So make sure you catch up on your integral techniques. Okay. All right. So let me go back here. I'm going to go to my 100 integrals. All right, there they are. So if you've got your book, it might be helpful. It might be helpful to look at the book, or it might be helpful for us just all to look together at this thing. And I'll say sort of what I want you to do. And everybody just chime in if you got an answer, or I'm going to start calling on people in order. So number 1, all I want to know is what do you think you might use on that would be a good idea?
Parts.
Parts. Okay. Alexis, you can't answer the next one. That's right. Parts. Because it looks like X and inverse sine. What would you let U be, guys?
X.
X. Good. And then dV would be inverse sine. That's a good one. All right. Look at this one. You know what? I'm going to leave that's a weird one. Tell me what you think. Tell me what you think you're going to do.
Split it up.
Yeah, split it up somehow.
Then change it to cosine or something.
Well, if you change it to cosine, it would be something in the denominator, and that sort of always complicates things. Let me show you something here. You could split this up, but if you pull a secant squared off of it, the only thing that's left is secant. And that neither one of those is the derivative of the other one. So this is looking a little bit weird. But if you have, I'm gonna make a note in your book. If you go back to integration by parts, which was in section 9.1, there is a problem. It's example 6 on 460. All right, example 6 on page 460. Example 6, 460. They split it up and do it as parts. That's one of the harder problems in this section right here, okay? But they split it up and do it as parts, and then they have to do another integral on it. So that's a good one to look at, but that's a harder one. All right, how about 3? What about 3? Just don't worry about the limits, but what do you think you might try on that? Actually, you sort of had one like that the other day. If I had log t and there was nothing else there, or log x and there was nothing else there, what could I let u be? I mean, I already told you the answer by asking you the question. You might say, let's try parts on that thing, right? Because if you, let's look at what we might do here. Get it out of the way. If I let, what was it? The integral of the square root of, integral, was it log of 1 plus x?
Yeah.
Dx. I sort of understand there's a 1 there. And I don't know what else to do with that. I mean, it's just, there's nothing else to do. If I let u be log 1 plus x, it'll make du easier. What is du for that one, guys? What's du? 1 over 1 plus x? What's going to let you dv then be? 1, so there's nothing left, right? Integrate that, you get x, so you get uv, so x log 1 plus x minus v du. I kind of like this one too. 1 over x plus 1 dx. Now, sometimes you start out with one method and you might have to do something different. When you look at this thing, take a hint from a recent conversation. That's a rational form there. What do you notice about that rational form?
The power.
Power in the numerator is the same as the power in the denominator, right? That's where I can divide. So I might, and it's, you don't want to try parts on this thing because there's no way to split it up to make it look nicer. So if I said just to practice division again, what's x into x?
1.
1. Multiply out. Subtract. Can't divide x into minus 1, so it's minus 1 over x plus 1. Not hard to integrate now. Not hard to integrate. Because that thing's, the integral of that's going to be 1. The integral of that's going to be log x plus 1. So when you see a rational form and you got the power the same or higher, do the division first. All right, let's go back to the sheet. What time is it? We got a couple more minutes. What would you do on number 30? That's an interesting one. 2x plus 1 over x plus 5 to the 100. 2x plus 1 over x plus 5 to the 100. That's a little funky looking. I don't think you're going to use partial fractions on it. Why? What would you have to do to set it up, guys?
Break it down to 99 parts.
Yeah, you'd have 99 things out there. 1 over x plus 5, or a over x plus 5, all the way up to a over x plus 5 to the 100. That's out of the question. So when I see something like this, I kind of think miscellaneous things. And when I see rational things to integrate, I think, man, if that were just a monomial, I could divide here. So I'm just trying to get a u and a dx here, guys. Anybody got any suggestions for you? Just take a stab at it. Suggestions for you.
Oh no. I guess x.
Say it again.
Oh
X?
no.
Well, if you let u be x, it just changes all the x's to u's. So that doesn't help me very much. But actually, that's a good thought. One reason you might let u be x is because du's dx. You can get more for your money here if you let u equal x plus 5, because then du is still what? Still dx. Now you look at it and you say, oh, well, then that's u to the 100th. Dx is du, u to the 100th. Dx is du. I need this in terms of u. Do you see a way for me to get this in terms of u, guys? All you got to do is replace the x. What you going to use? What is x, guys? Yeah, x is u minus 5. Just using that other one. This is what miscellaneous substitution is all about. So now it looks like 2 times u minus 5 plus 1. Dx was du. This is u to the 100th. What I did was make that binomial right there to a power into a monomial because I saw I could get a handle on x. And now I'm going to say 2u minus 10 plus 1, 2u minus 9 over u to the 100th. Did I do that right? Minus 10 plus 1, yeah. Now it's just a common, 2u over that will be 2 over u to the 99th. Easy power rule. Minus 9 over u to the 100th. That's 2, and that would be an easy power rule, and you got it. Okay. So everybody see what I did? You got to strike out with something, and if it doesn't lead something you can integrate, you just start again. You don't always start in the right place on these things.
I just don't know where we got the x equals u minus 5.
You don't understand that? Is that what you look? Okay, this is, when you do your substitution, this is yours to use. And you know what? Since I'm trying to write all of this stuff in terms of u, I could write that. X is u minus 5, so I'm just going to put in right there. For that x right there, I'm going to put in u minus 5, and now the whole thing's in terms of it. So this is a more complete way to use your substitution. Not only have you used it for a du, but you used it for part of the integrand here. You've used it for fixing up something else that you needed to change. Does that make sense, Alexis? You see what I can use it for all kinds of
I'm just still confused. Like, I'm just like, when have we ever said x equals u minus 5?
We haven't. That's the whole point. That's why this is a miscellaneous substitution. Because
I was just like, this looks foreign to me.
Well, that's fine. It is foreign. It's new. The thing is, what happened here is that you got to get this whole thing right here, all in terms of u. We did part of it. We got the du was dx. We got the x plus 5 was u to the 100. You only had this x, but this thing you can use any way you want. If you want to substitute, if you want to get things in terms of u, then solve for x in terms of u and put it back in. The whole point is to get this whole thing right here with just u's in it. And you can use whatever your substitution says to do that. Okay? All right, it's about time to go. Let me see if there's anything else that looks remotely like that. Okay, look at number 16. And then I'll quit. Okay? If you look at 16, x minus 1 over x plus 2 to the 5th. X minus 1 over x plus 2 to the 5th. X minus 1 over x plus 2 to the 5th. Now, guys, you could use partial fractions on this. You'd have to put a over x plus 2, b over x plus 2 to the 2nd. You'd have to do 5 things. What do you think, based on the last thing I did, what do you think you ought to be here to just avoid that altogether?
X plus 2.
X plus 2. Okay, so let's let u be x plus 2. Then du is dx. So I'm going to substitute there. That's u to the 5th. That's du is dx. So I put du in dx place there. This is x minus 1. You want it in terms of u. Here's your connection. What is x, guys? What is x? It's u minus 2, isn't it? So all you're going to do is put in the place of that u minus 2, and then you got the minus 1, and that's u minus 3 over u to the 5th. So you see, Alexis, I just used my substitution in a different way. I said, I got an x up there. How am I going to get rid of it? I'm just going to solve for x. Then it's easy, split it up. U over u to the 5th minus 3 over u to the 5th. 2 easy substitution. I mean, not substitutions. They're actually two power rules. So that's 1 over u to the 4th minus 3 over u to the 5th, and those are easy to do. So that's a way we might use miscellaneous substitutions. So tonight, if you did not look at the miscellaneous things, try the quadratic homework and the miscellaneous homework, and we'll talk about problems that you had on that. And then we're just going to do the same sort of stuff we're doing right here. And I would like for you to, I'm going to pick out random things from here, but the one I want you to look at is on Moodle, and it says class exercise. And I want you, there are 12 integrals there. And I want you to do as much as you can on those 12 integrals, and then we'll practice some more on these 100. But do as much as you can. Work them like it's a quiz. It's not a quiz. Here's what I usually do with this in class, in case you want to know. I would have split you up in pairs. And I would have said, okay, I want you to together to brainstorm about what this ought to be, about what we should try here. Tomorrow, I may try some version of that. But I want everybody to have looked at it. There's, again, it says class exercise on Moodle. Look at those, try to work them. That'll look like your next test. That looks like your next test. Okay, it's just a bunch of integrals. What am I going to do with them? All right, anybody got any questions, comments? You okay? All right, so tomorrow at 1, more integrals. Look at the homework, any of the homework you haven't done, and then look at that sheet of class exercise integrals, okay? All right, I'm gonna sign off. If y'all are ready to wave goodbye. See you later.